this segment, we'll discuss how to traverse a container class using iterators. Let's quickly review iteration on a list. For an array list or a vector, we can use the subscript operator. So recall that for a vector, we have random access in constant time. And what I mean by that is that the subscript operator can permit you to access any element in the array or vector in constant time. So in this for loop, we can go through each element in the vector and access it to print it in constant time. But now let's see what happens with a linked list. So here we have a linked list of integers, and we want to traverse it to print out all the elements, but now we have to recall, how do we access element I in a linked list? So to access element I in a linked list, we need to traverse from the head to I. And we can see this here. To get the first element, the head, we already have it. To get the second element, we have to go through the head and then get to it. And then the third element, we have to go through the previous two elements. So we have to traverse from the head. So to get the ith element, this is going to be I steps of work. And this would turn out to be an extremely inefficient implementation, because in order to traverse a linear list, this would then take n squared work, where n is the number of elements on the list. Whereas with a vector, we can traverse in linear time. So what we want is we want to be able to traverse our list in linear time, whether it is array-based or linked list-based. And as we saw, because random access is not possible in a linked list, we actually just have to traverse from the head to the ith element. We have to see how we can do better. And iterators are what permit us to do better. Okay, so an iterator is an object that permits us to keep track of the internal location within a container class. And a benefit of iterators is that they provide the semantics of pointers, and we'll see that in a moment. In order to get the first element of our container class, we have to call the function begin on our container class, and it will return an iterator to the first element in our container. So just to see this now, we declare our container class. So this is our linked list class of integers called myList. We want to get an iterator to the beginning of the list. In order to do that, you'll notice that we use the name of the iterator, and then we call the begin function on the iterator. This iterator will be pointing at the first element of the linked list. And we'll talk a little bit more about a little bit more care in declaring our iterators, but for right now we're just trying to introduce the notion of an iterator. So here you use begin on a container object in order to get the iterator to the first item in the container. And then in order to tell when you're at the end of your container, or one past the end, you use the end function on your container object. So that's right here. If I want to check if I've exhausted my container, I will call end on my container object. And what this does is that it returns an iterator for one past the end of the container. Now, if I want to advance to the next item in the container, I need only increment the iterator. So as we can see in this for loop, if we want to go through this entire linked list, we initialize our iterator to be the list beginning, which is mylist.begin. As long as the iterator is not equal to the end of the list, which is mylist.end, we increment the iterator. Then, if we actually want to see the contents of the current element in the container class, we need only dereference that pointer. And that's what we meant by that iterators provide pointer semantics. So this for loop would print out 3, a new line, 9, and then 5. And as you can see, when we initialize it, the iterator would be pointing at the 3, then we increment it, and it would be pointing at the 9, and then we increment it, and it would be pointing at the 5. And then once we increment it after printing the 5, it would be returning mylist.end. Now, here's a bit of the care that we have to use when we are declaring iterators. So iterators are defined in the scope of the container. So this is the care. So in order to instantiate an iterator, you actually have to have the type be the name of the container class, the scoping operator, and then the word iterator. So for example, you can have an iterator to a vector of ints, and that's the type. And as we saw previously, when we want to initialize the iterator, we have to make sure we use an object name of that type and call begin on the object. And if we want to check for the end of that object, we have to use the end function on that object. And then once again, we can move to the next item in the container by incrementing the iterator. So let's look much more carefully at this now so we can be specific about the syntax when we're using iterators. So first, inside main, we declare a vector of integers, and we just push back the numbers between 50 and 54 on into our vector. Now we want to go through our vector, and in order to do this, we declare our iterator. When we declare an iterator, we want an iterator to a vector of integers. So you'll notice when we declare our iterator, we have to make sure we specify that it's a vector of integers, the scoping operator, name iterator, and then the name of our iterator variable right here, which is just it. Then to go through the elements of our container, we have to use, you'll notice here, and this is the important distinction, that here, when we want to call begin, you have to call begin on the object, which is the actual container object. You call begin on the object in order to get an iterator to the beginning of that container object, and you call end on the object in order to get the iterator to the end of that container object. And as before, we could advance to the next item in the container by incrementing the iterator. But the care, there's two aspects of care that we have to have when we're using iterators. The first is we have to be sure that we declare our iterators with the scoping operator to the type of container object for which it's an iterator. And the second is that whenever we want to initialize an iterator or we want to check the end, we always have to call begin and end on the container object for which we want the iterator. So as we had mentioned before, the iterators have the semantics of pointers. And what we mean by that is that given an iterator, then you can actually access the elements within the container using pointer semantics. So here we have our vector of integers again, and as we had just seen, we can declare an iterator to a vector of integers. We can get the beginning of the vector object that we just created. We can check that the iterator has not gone past the end of our vector of integers, and we can advance our iterator to the next integer in this vector. Now if we want to print it, we can use the star operator on the iterator in order to access the integer in the container. And to do that, you'll notice we use star and the name of the iterator, and that will give us the actual item in the container. So for example, if we had a vector of strings, when we dereferenced it, we would print out a string rather than an integer. So if we had a vector of characters, if we dereference the iterator, we would print out a character instead. So the iterator can be thought of as pointing to the current element in the container class. Now, C++ STL algorithms uses iterators, and for example, with the sort or the count function, we pass iterators to the beginning and the end of the container objects upon which we want to apply these functions. So let's look at an example with sort. So we create a vector of integers and we push in random integers into our vector. Then, if we would like to sort our vector of random integers, you'll notice that we pass two iterators. We pass an iterator to the beginning of the vector of random integers we've created and to the end of the vector of random integers that we've created. And then when we go through the for loop, we will print out all of the random integers in sorted order. So key point is that we can pass iterators to the beginning and end of containers to functions. And if you wanted to only sort a subset of the vector or only a portion of the vector, you can also pass the iterators to just the portion of the vector that you wanted sorted. But most often you'd want to sort the entire vector, as in this example.